Hello, my name is John Marcial, and I'm team leader for Team 13. We are building a control software for tensegrity robotics. Tensegrity robotics are physical systems held together by tension cables. Because of this, whenever they are unstable, they move to equilibrium. We are building control software that easily manipulates this for you. It allows beginners to actually have a better experiences working with tensegrity robotics than normally available in the current market. It's also not just for tensegrity robotics, but it's also for universal robotics as well. So long as it connects to Bluetooth or USB serial for Arduino, it doesn't matter. You can control it and optimize it however you like. It is fully customizable for you.
During concept development, we focused on selecting the most convenient solution for our idea. For this, we created a concept fan to visualize alternatives. In this diagram, each line represents a subset of alternatives for each category. We then combined ideas into sets of solutions. We considered materials for the frame of the robot, the type of sensors to be used, and the microcontroller that would enable communications between the robot and the signal processing device. We then weighted the advantages and disadvantages of each option and assigned importance to objectives. By evaluating each alternative against each other, we determined that the most optimal choice was option C. We decided our tensegrity robot would consist of a PVC frame, a digital camera-based sensor, and an Arduino microcontroller.
The signal for our TenseBot system is in two forms: color detection and GUI menu control. The program starts with you selecting a color from your choosing from the provided list. After this, you can start collecting data from our camera auto control mode or from our GUI menu control mode. This data is then sent to our Python program to collect the coordinates and transfer it to Arduino. The Arduino is working with our shield that has 3 motor drivers on it to control the system. Once all the data has been collected, our TenseBot system will move the robot with 3 motor drivers. To recap signal processing is as follows: color detection, GUI menu control, coordinate generation, and transferring data to Arduino to move the motor.
First, we initialize the interface. This is where our journey begins. The interface is set up to be user-friendly and intuitive, ensuring a smooth experience for all users. Next, we move to setting up communication parameters. This step is crucial as it establishes the necessary connections for the GUI operation to function effectively. Once the communication parameters are set, we proceed to the main operation of the GUI. Here we have 2 primary actions based on user input: color detection and button selection. In the color detection process, the system identifies the color input by the user. This feature allows for a more personalized and interactive user experience. Simultaneously, the system also waits for the user to select a button. Each button triggers a specific action, providing users with control over the operation.
Our tensegrity robot hangs within a PVC frame. It consists of an electronic control unit, 3 stepper motors, and an emergency stop button. The ECU sits on top of the frame and controls the stepper motors that reside beneath it. The stepper motors actuate the robot's movement. The emergency stop button can be pressed to cut the power supply. The ECU is controlled wirelessly by the GUI.
The GUI acts as a universal remote for all different types of robotics. You can connect to different devices using the COM ports menu. If it's a Bluetooth device, it will let you know that it is a Bluetooth device. If it's a USB serial, it will let you know what device you're connecting to. You can send messages to the targeted device at different speeds with the baud rate menu. If you have a visual component, you can select what type of color you're using to detect. Then you can connect the device and disconnect the device under the connect menu. We can select multiple different types of colors to detect. Right now we can select red, show it to the camera, and it will detect the red. In real time, once you click colors detecting and switch to blue, you can switch it to the blue object and it will work seamlessly, no lagging in between. Here's an example for green. For this particular demonstration, we can send our robot to the right and it will go to the right, home to 0, 0, and then go back up.